What's up guys, Maindric here. I am making this video kind of as a follow-up to my prior C# versus GDScript performance video and how I had made a couple incorrect conclusions. However, that has also led to the more widespread of some other misinformation. So I wanted to clarify what I was trying to say and kind of my point with the video. I had made some claims that if you're using C# to do something like opening a door or some basic scripts, that it could be slower. I said it more matter-of-factly in that video. However, that was probably a stretch of the conclusion. However, the reason I came to that conclusion is still valid. I made the claim that using C# in Godot has some form of overhead. And in this video, I'm going to demonstrate what that overhead looks like and the performance differences that you'll have with it. And I'll explain why I'm pretty sure what's going on with that. So let's go and load off by this project that you see in front of you is actually available in the description down below as a GitHub repository, and you're able to run this for yourself. So you can see it, you can see all the code. I'm not trying to hide information or anything. So let's get moving with it. So what this is testing purely the data processing capabilities of the different languages and the different implementations within Godot. So what this does is it creates a pretty lengthy array of just integers, and I perform a sort algorithm based off of, actually the array.sort is just the array.sort algorithm within Godot itself. I believe it uses some form of radix sort or something. I'd have to look it up. I think it's something different, but I digress. That was just as a control, just to have something there. But what the rest of these are running are actually a form of merge sort, which I chose this algorithm for this test purely because it is a stable sort algorithm. There shouldn't be any wild numbers thrown out there. That's not unexplainable anyway. That's not explainable. Which is why I chose this. I didn't want to have any systems in here that are measured by anything that could be slowed down due to graphics or anything else. I wanted this purely a computational workload done purely on CPU. You can see me kind of clicking through here. The performance numbers on the C# first time you hit perform is going to be high. I believe this is something to do with a just-in-time compiler for the C#. However, I can't demonstrate that fully, except that the first time you ever use it, it's always going to be a higher number. It just is what it is. But as you can see already, I have two different C# here. They're both running the same exact script. However, what differentiates them is how I'm invoking that code. So when it comes to GD to C#, when I click this button here, what's happening in the code itself, you'll see here in, I didn't rename the function from my first time I wrote it, so I left it as on CS button. So this is on C# button. So there's a button called C# button. When it clicks, it comes into here. And what it's actually doing is going to the C# merge sort and just invoking merge sort directly. And that's all it's doing, is it's simply taking the current time, invoking merge sort, getting the end time, and telling you how much time has passed. This is using nanosecond ticks. That number is going to be unreliable. It's going to fluctuate all the time. That's fine. It's more just for demonstration. This isn't a wholly scientific method. However, if you get enough measurements, you can kind of draw some general conclusions. However, when it comes to C# to C#, what you're looking here is I made the full CS button, and this is where the new code comes in. I added the function start bench within the C# merge sort file. So let's go ahead and open that. Oh, I don't have the folder open. Let's go ahead and open that folder. Yes. Yeah, I wrote it. Anyways, let's go to merge sort.cs. And let's take a look here. So what we're looking at is a start bench and end bench. I just simply brought these functions over directly from Godot and then converted them to C# to get them to run here. But what's ultimately happening is this is the function that's called from Godot or GDScript, and it passes in the array here. But then inside of this function, after all that's done, is where I actually take the time and then run it, and I take the stop time. And what this is doing is it's not doing the conversion of the data from GDScript to C# while the timer is running. That's the difference that's going here. So the time that both of these functions take to complete likely isn't any different, but by just simply moving where I'm calling this, we can see a massive performance improvement. The reason I bring this up is just so you can understand what's going on in this test. So if you want to test this yourself, you can download this project on GitHub. I am going to go ahead and build this project and run it compiled so you can see exactly what the performance differences are. So let's go and add a Windows desktop export. Let's make a new directory .builds. This .builds is not going to be included. Executables aren't really great for binaries, so let's do csgd perf test.exe, and it's going to export it. So then we can go to the export here, builds, and run it. This way we're not running into any interpretation issues. We're running a raw binary file. So this benchmark button, what it does is just goes through a bunch of different lengths of arrays. And this is where I got my graph data in the other video. Yeah, threaded issues, not important. It's not going to impact this whatsoever. Yeah, the two threads implementation here is just simply to test threading in Godot, and it's kind of a pain, truth be told. This is not the greatest way to do threads. I would not recommend using threading in this fashion. I was just testing for fun, so you can ignore those results, truth be told. All right, so when the results are exported, they go into the little folder. Where is it? I have it open already. Yeah, no, this is not it. Yeah, this is it. Yeah, for me, it goes into my apps data roaming Godot app user data perf test, and I output the CSV file. And these are all the times for all the tests that were run. How it goes through is there's 100 runs over, what is that? 15, I want to say. Yeah, 15 different lengths of arrays. And you have your control. This is array.sort. These are the times for that. Usually you can safely ignore, that's probably right after the error is thrown. We can throw that out. We can ignore that. We can ignore that one too. Yeah, this is going, and honestly, these kinds of erroneous results are why I'm saying that using just the UTIX, the nanosecond ticks raw, you can't just look at them one-to-one. That's why I did 100 runs, and actually in the video I did like 3 iterations of this and averaged them all together. Is how I got those numbers. So it's not just one run. I wanted to make sure that any error issues were kind of brushed out. But the interesting thing is when you come down here, these are the results I used in the video, because I didn't go so far as to keeping the data within C#. And if you notice, ignoring the first run, which these two are usually bogus, you can see the performance difference here. Going down through here, they're all nearly ones for CS to CS. Whereas if you look at GDScript, there's not a single one that is 1 nanosecond measured in here. And if you go so far as like, let's look at length 128 versus length 128, you can see that there's a near like 12 nanoseconds. Generally speaking, I can actually average them together, so I can kind of prove this. So let's do equals average. What is it? A3 to CW3? Yes. I had a typo. Oh, I didn't spell out average. RIP. All right, and then I can just drag this down. Once again, there's going to be some erroneous numbers in here because I didn't clean up the data at all. So these results aren't filtered. They're just raw numbers. But what we're concerned with are these last two right here. So if we convert the, let's see. Oh, it's been a while since I've used Excel. What I want to do is remove the, I wonder if I can just simply copy those and remove as, and paste as data. Yeah, paste as values, that's what I wanted to do. So this right here is CS to CS, and this is GD to CS. All right, so this is kind of what we're looking at here. And actually, let's do make this equal to that divided by that. And what this is showing us is how much time, and we can change these values to, let's see, format percentages. So staying straight C sharp is actually, wow, that's actually quite an outlier there. What's going on there? 1, 2, 3, 4, 5, 6. Actually, I can just do this. Do I start at 1? Let's drag this all over here so it's easier to look at. I can copy these here. So these are the array lengths. So at 128, there's actually an outlier there. Oh, so something happened there that slowed the test down. Do keep in mind while I'm doing this, I'm actually also doing the video recording on the computer, so these numbers are also just all kinds of fudged up. But that should be enough for a quick demonstration. And once again, you can run the code yourself and see what you get. But generally speaking, if we have the data already in C#, sending it to C#, it's always faster. Except for this one time where there's a 2000. I guarantee you, if I remove that 2000 result, if I filter it out, where is it? I forgot where it's at. This, ladies and gentlemen, is why I don't record live videos, but I want to be as transparent as possible in doing this. All right, so let's say that's more in line with the mean. So let's say I'll go actually above. I'll do 30, just for the sake of example. That shot from 43.75 to 16. So that is really the only result that caused this to happen. And 35, as you can see, is well above the average, seeing as the average is 16. So this is a bad result. I wouldn't use this for an actual analysis piece, but this is just a demonstration. And I think this kind of gets my point across. And on to my explanation of what's kind of happening here. When it comes to the code, when you are in purely GD script and you're passing data through, things are able to be passed through pointers. It's able to be passed by reference. What that means is that it's just passing in where in memory the object is stored. However, variables and data in Godot and GD script is not directly convertible to C#. So what's happening here, why this shows such a much shorter amount of time, is the conversion of this array right here is happening before the time is taken, and the merge sort, which is returning an array itself, that's not being converted at all. Whereas when you call the GD script to, where is it? GD script to C# implementation, right here, we take the time here, then it actually has to convert this array right here into a C# array, pass that in, but then it also has to, this might not be necessary anymore. I remember when I originally wrote this, I had to pass in the array as an object. However, today when I was mucking around, I was able to change it to a integer array, and it's actually not passing any errors, which removing that might be faster because that's actually creating a new array with the data inside of there. So that might actually speed the results up quite a bit. Once again, this is kind of done on the fly, my apologies. And in here, I'm not doing it all. So in the benchmark, that step wasn't even happening, so it doesn't even matter. It's not significant. The benchmarks aren't affected whatsoever. because this is the actual benchmark function going on right here. These button clicks, I actually use them for debugging. If you notice at the end, I had a is sorted function that just goes through the function, make sure it's actually sorted, and I'm not actually accidentally mucking up the algorithm, or to verify that the data is actually going in correctly. It's a error check. But in here, what's going on here is the array is actually being returned into GDScript. It's not being used, but it's still being returned, meaning it still has to be converted. So that's extra time. That's the overhead I was referencing. It's the data going from one type to another that has impacted those values. This is where I'm saying I was wrong when it comes to using GDScript and C# to open a door. A simple thing like that, just calling a function to open a door. When you use open door, you might not be passing in any data or receiving any data, so no data conversions happening, so there shouldn't be any overhead in those situations. However, if you're passing in data, as I've demonstrated here, especially when it's a simpler, smaller length arrays, the difference is significant. So much, like down to 7%, which this is probably including, actually, it's kind of in line with this, so I wouldn't even say that's an outlier, but this is, I want to say, shockingly slow, but then again, an array length of 4, whatever, doesn't make a difference. It is what it is. My point is that when passing data along, there is overhead when going from GDScript to C#. Make with that what you will. But I think it's undeniable that something is happening when the only difference is where I'm taking that time. I hope you found this video enlightening. I hope to make more videos in the future, but I tend to be quite busy. But for now, I will continue with the Godot Wild Jam. I will see you guys later.